And girls, today we are going to get into our section of matter where we are talking about the sum of parts. And what that's meaning is the weight of something is equal to the sum of its parts. It's really a pretty simple concept. Now, there is a law of conservation of matter and mass, and this is in your note sheet. That's important. So remember, matter cannot be created or destroyed, only changed. Okay? And we will talk more about that as we get into physical and chemical changes next week. But just like we have our a tall tower of blocks and we knock them down, it's just changed. Okay, we've changed the way it looks. Like when we add sugar to our sweet tea, we've just changed it from what it was. It was that plain water, and now it has that sugar in it. All right. So there are differences in mass and weight. So we need to make sure we understand those differences. Now, the mass is the amount of matter that makes up an object. So mass is how much matter is in something. Weight is the amount of gravitational pull on an object. So that's why weight we hear, and the example we use a lot is that you weigh less in space. So, if you don't like your weight, you can say, oh, it's gravity's fault because it's the amount of gravitational pull that an object has. All right, so let's think about it. Like we were just saying, on Earth, we have gravity. So this ball has a mass of 10 grams and a weight of 2 pounds. But in space, there is no gravity. But that ball has the same mass. It still has the same matter inside of it. But it has no weight because there is no gravitational pull. Okay? So that mass is how much matter, what is that stuff inside of something. Okay? It's still going to be there whether it's Earth or space. But the weight is different because weight is because of the gravitational pull. Okay? So what about this ball? The mass, 20 grams. The weight is 4 pounds. Again, in space, mass is still 20 grams, but it weighs 0 pounds. All right, so these astronauts, or this astronaut, Neil Armstrong, the first astronaut to walk on the moon. His mass is 1,500 grams, and that is on Earth. And this is just a little off right here. In space, he's still 1,500 grams. His weight's 200 pounds on Earth. His weight is 0 pounds in space where there is no gravity, okay? There is no gravitational pull. Now, the main thing we're going to be talking about this week is the sum, and we talk about sum in math a lot. The sum is the answer when you add. So the weight of something is made up of the sum of its parts. Adding together its parts is going to give you that total weight. So in this picture, if we look at this house, let's think about the different parts. We've got our house, our roof, our windows, our doorknob. Each part has a mass. The roof is 15 grams. These windows are 10. So is the door. Bottom part of your house is 20, and that doorknob is 5. Okay? So part of what we're doing in science this week is very simple math. This is the time in science where, it's not a lot of tricky vocabulary. We're doing some simple adding. So this is a nice break. Okay, so you may be asked questions just as simple as this. What is the total mass of the door and the knob? Well, we know that's 15. Our windows, 10 and 10, that's 20, the whole house. So that might be where we need to take that picture out and or our paper out and add it up. Okay, but we've got 20, 30, 40, 50, 65, 70 total. Now, this house has only one window, so if it was 70, we took away 10. Now this is only 60. All right, so we've got another one. We look at this cheeseburger. What are all these parts? We've got our bread and our tomato, and our lettuce, cheeseburger bun. So again, you may be asked something just as simple as, what is the mass? What is the total mass? That means what is the total of all those parts? Okay, so we would add that up. 12, 5, 5, 6, 7, 10, 11. And we would get 56. Okay. Okay. Sarah and Jose are making lemonade. They are using the following ingredients. 35 grams of water, 4 lemons that are 10 grams each. So be very careful when you see something like that. That means it's actually 40 grams since each one was 10. 24 grams of sugar, 20 grams of ice, 50 grams. That is the weight of the pitcher. What is the total mass of the lemonade? And that would be 169. We'd need to add all that up. So if they add 3 more lemons, we would add 30 more grams to that mass, and it'd be 199. Okay? And if they were thirsty and drank 4 glasses and every glass was 15, how many grams would be left? Again, we've been adding and subtracting. First, we'd need to figure out, well, if one or each glass was 15, and I have 4 of those, I'd need to figure out 15 times 4. I use the clock to help me. Think about 15 minutes on your clock. 15, 30, 45, 60. So we would take 60 away from that total and get 139. Okay? And so this is the type of things that we might see. The total mass of this recess bag, because it is the sum, the adding up of its parts. We've got to add up our soccer ball, our basketball, our frisbee, our football, and our bag to know what the total of that whole thing is. But the football got lost. So if the football is lost, we need to be able to look at this and say, well, I know that I would take away 32 grams to get my new mass of 86. Okay? So here in this problem, we may see problems like this. We just need to read the directions. She's making a sandwich. We need to add these parts together. The bread, the cheese, the turkey, the tomatoes, the lettuce, to find that total mass. Okay, and she ate 4 bites. Every bite was 6 grams. What is left? So we would need to say, well, I know 4 times 6 is 24, and I could subtract that and get 67. All right, but keep in mind, what is the total mass of this block tower? So if all of these are 5, 5, 10, 15, 20, 25, and it falls over, and we add up these pieces, what is the total mass? It's still 25. It doesn't matter that it's knocked over. These parts still have the same sum, here or here. If Molly stirs 20 grams of salt into 60 grams of water, what will happen to the mass of the water as the salt is added? Okay, our mass is going to increase. Now we might think, well, if I put salt in there, it's going to kind of disappear and I won't see it, so it must still be 60, but that's not right because you are adding that mass in there. You're adding those 20 grams. It's going to be 80 because you have added that in there. Okay? Mark made a batch of brownies. The entire pan had a mass of 350 grams. He cut the brownies into 14 equal pieces. What is the mass of each brownie? So that goes along with what we've been doing with division. We've got these equal pieces, so we know we're going to divide those two. And when we show that work, that is 25 grams. Okay. If we get the information, Maria decided to build a tower using 20 blocks. Each block has a mass of 7 grams. The total mass would have to be, we could look, we know 7 times 2 is 14, so 7 times 20 would be 140. So, does the mass of an object equal the sum of its parts? Yes, it does. Yes, it does. That's what we're saying. So, if you have a tower of Legos and you take them apart, the sum of those parts are going to equal what it was altogether, just like we saw on our video, or like we're going to see on our videos later this week. Also, if I was to have a toy car and I took it apart and I had the engine and the wheels and the steering wheel and I weighed them separately, it would still equal what it did when they were all together. So it's very important to remember mass equals the sum of its parts, the adding together of all those parts. All right, boys and girls.